And again, it started in its roots by just developing matrices. So say, for example, we have matrix A, right? To make a matrix, you open the square bracket. So say we want a 2x2 matrix, right? So we want a matrix. We have our matrix here, and we have 2, -2, 2, and 2, right? Right. So in order to make this matrix, we open square bracket, we go 2 space -2, right? And then to get to the next row, we hit the semicolon, and then 2 space 2, and then close bracket. So if we hit enter now, you will see the matrix like that, right? And then if you click on the workspace, you double click on the variable name here, you will see the open 2, 2, 2 -2, 2, and 2, right? So each cell and each column has a designation. So this here is 1 by 1. This here is row 1, column 2. This one is row 2, column 1, right? So that's how we designate each element. And so if you want whenever it is you want to recall a variable, or recall something that you type in this workspace here, sorry, in the command window, you press up on the keyboard. So you don't have to type it over. Or you could just come to the bottom here. Let's backspace this. You could come to the bottom here and you could see where you have the A matrix defined. You could just drag it across. Right? You could come here and drag across the clear all also. The error there, you could just drag across the clear all, and you could clear the workspace. All right, so if you want to have the matrix here, but you don't want it displayed again, because remember when we hit enter on top here, you saw the A here, right? You put the semicolon there. So when you hit enter, it will stay in the workspace, but it wouldn't show up here. Right, so that is how you define a matrix. Right, so you could do things like find the inverse of a matrix. You go INV for inverse. You put in the matrix A and enter. So this is the inverse of a matrix of this 2 by this matrix here. Right, if you want to find the transpose of a matrix, I remember transpose of a matrix would be when you switch rows with column. So you type A, you type the little what do you call it? Inverted comma, hit enter. So it transposes the matrix here. So the row turns into the column. Right, just to see it a little better, I'll create another matrix here. 1, 2, 3, 4. And so B transpose, you could see it's flip the row with the column as what a transpose would do. Right, so if you want to multiply something by a matrix, we just 2 by A, right? So that is matrix algebra in a nutshell. Then. Right now, there are other things in MATLAB that commands know that could build upon this, and we will use it for one of the examples we did last week. All right, so you all still see the MATLAB screen, or you see the PDF here?
It's in PDF.
Good, right. So now I know that working. All right, so this was the example we did last week, right? And we had a connectivity table, and we formed the global stiffness matrix, right? And this was the matrix set up for it. So we had 1, 2, 3, 4 unknowns, and well, there's a 4 by 4 matrix. We have 4 equations, so we was able to solve for it, right? But if you write to the matrix side, it will look like this. But again, we should have MATLAB do this for us then. It should be able to simplify this process. Right now, elimination method and all the other methods, as I said last week, was really different tools to get around doing all the maths if you're doing it by hand. finite element software will also employ tools like this because at the end of the day, they're dealing with matrices that have dimensions in the order of hundreds or thousands, like 100,000 columns or 100,000 rows. So they will look for any method in the algorithms to kind of simplify it. Right, but we're not going to go into that. As I said, that is numerical methods. We're just looking at getting up the matrix setup here. Right, the equations that govern the system. So if you solve the equation, you will get the unknowns, which was D2, D3, R1, and R4. Right? So we have some unknowns, right? So how are we going to deal with these unknowns? By hand, we would write D2 is equal to whatever equation we will solve it, right? But in MATLAB now, we need to kind of let MATLAB know that we're dealing with an unknown in the form of a variable. So what we could do, well, what I'll do here, CLC, I'll clear the screen here. We could say something called SYMS. Right? SIMS is something is short for symbolic. And there's something called a symbolic toolbox in MATLAB that allows us to deal with equations, but in terms of symbols, like how we would normally do by hand. So we could say SIMS is X and Y. Right? So we have two symbols like that. And then we could come now and say Y is equal to 3X plus 2, for example. So we have Y now expressed like as a symbol. Right, so imagine we have an expression now. Right, so imagine we have an expression, say 3x plus 2 is equal to 0. Right, so we have one expression and we say, oh, find x. Right, so how we would go about doing this in MATLAB? Well, then in this case now we say, okay, we could say let the I equation equal to, let's say y. Right, and y is 3x plus 2. Then we could say solve. All right, I'm gonna try this again. Y is equal to 0. Right, so because 3x plus 2 equal to 0, right? So the equation that we want to solve is really y is equal to 0. And we put 2 equal sign because we wanted to, because it's not a numerical equation we're writing, we need to let MATLAB know, well, it's an equation, but in a symbolic sense. So we put 2 equal signs. Enter. So then we could say, okay, let the solution to this equation be, solution be, we use the command solve. Right, so that's another toolbox. Right, so this solve command I wasn't finding in 2010. Right, so we say solve, open bracket, the equation we want to solve, and we want to solve it in terms of x. Hit enter. So it gives us a solution for x as minus 213. Right, so it actually solved for x there. So that's how you could use MATLAB and the symbolic toolbox to solve big, long, complicated equations. Right, so you notice how I enter the equation here. I say the equation be y is equal to 0. And I put these square brackets indicating that the MATLAB, it is the input is in the form of a matrix, but this matrix only has one row. But because in the matrix from now, you could have an infinite number of rows. So you could have 4 equations, you could have 5 equations, 6 equations, etc., and have 6 unknowns, and MATLAB could solve it for us. right? So this is why it takes away the need for having to do manual or bulwark type calculation when you're doing your research and development. Right? And that's the intention of this course on the final year, well, the final semester, so they kind of bridge the gap between your undergrad and if it is you're going to do postgrad, and also how to leverage modern day tools for your job later on. Right? You could even write, if you know MATLAB code, you become good at it, you could even write executable files and it will convert it to C++, and you could create a nice little program on your computer to do whatever task that you need to keep doing. Right? So you could use it as a normal programming language also. Right? So we're going to use this method now to kind of solve those that spring element equation.